dear student. Let's now solve question with free fall. Not necessarily that the ball is rolling on the ground, on horizontal ground, and it hits a wall, a vertical wall. We can just drop a ball and it hits the horizontal floor and it rebounds also vertically. It means we will deal with acceleration of free fall, which is gravitational acceleration. In Edexcel syllabus, it is 9.8 meter per second squared. In Cambridge, it is 10 meter per second squared. Let's start. A ball of mass 0.2 kilograms is dropped from a height of 2.5 meters, as shown in the diagram I drew for you, above the horizontal ground. After hitting the ground, it bounces to a height of 1.8 meters above the ground. Find the magnitude of the impulse received by the ball from the ground. I'll reread it. A ball of mass 0.2 kilograms is dropped from a height of 2.5 meters above the horizontal ground. We need to know information about velocities. The word dropped means that the initial velocity is 0. But we need to know the final velocity is how much. So now we can use kinematics rules. After hitting the ground, it bounces to a height of 1.8 meters above the ground. Find the magnitude of the impulse received by the ball from the ground. So we need to find in the first part the final velocity. If initial velocity is 0 and the word dropped means that, and acceleration is 9.8, so we remember that we need a formula having no time, which is v squared equals u squared plus 2as. V squared equals u squared plus 2as. The v, we don't know. Final velocity, it's the unknown. Initial velocity is 0 plus 2 into 9.8 into the distance, which is 2.5, and you just get v, it will be 7 meters per second. It will be 49. When you find the square root, it is 7 exact. And then it will rebound. It means that this, when it rebounds, or the free fall, it goes up at a final velocity 0, because it will reach its maximum height. Anti-gravity, it means here acceleration will be negative 9.8 for Edexcel and negative 10 for Cambridge. When dropping the ball, it's a free fall question, so acceleration is the gravitational acceleration. Positive when going down and negative when going down. So here is the next part of the question, which is, I need to know the initial velocity here. Initial velocity is how much when the final velocity is 0 and the acceleration is negative 9.8 and s equals 1.8. For the second time, I'm avoiding using time in the question, so we'll use v squared equals u squared plus 2as. Final velocity is 0. Initial velocity, I need to know. Plus 2 into negative 9.8 into s, which is 1.8. When you calculate the initial velocity, you will get it as 5.94 meters per second squared. Meters per second, I'm sorry. And now we'll go to the third part of the question of finding the impulse. Impulse equals difference in momentum, which is mv minus mu. mv minus mu. We need to find the impulse for this highlighted part. You know the initial velocity, which is 5.94, but actually when I take off this part, I'm concerned in, I'll redraw it here for this part of the impulse. Here is the ball, the mass is 0.24. It hits the floor with a velocity 7 meters per second, which we get it before, and rebounds with velocity which is 5.94. Remember that the direction of the impulse we mentioned is the opposite direction of the initial velocity. Initial velocity is 7, so I'll write it a negative 7. And the final velocity is 5.94 in the same direction of impulse, so it will be positive 5.94. Now mv minus mu, the mass is, I can take m as a common factor, so m will be 0.2 open bracket, final velocity which is 5.94 minus 7. 5.94 plus 7 into 0.2, we will get the answer 2.59 Newton second. Next, we will resume and take extra information about this issue, which is collision. Today, we will learn the principle of conservation of momentum. The principle of conservation of momentum concerning collision of two cars or two balls or any two objects, both of them are moving. The total momentum before collision is equal to the total momentum after collision for the whole system. It means I'm concerned in velocities before collision and velocities after collision. Okay, now let's stress on this part. The principle of conservation of momentum is that the total momentum before impact equals the total momentum after impact. What's the meaning of total? Total means you will add momentums and you will equate before and after for the whole system. It means here I have two balls. This ball, the mass is m1 and the second ball of mass m2. They are moving. Suppose that both of them are moving, two cars after running in the same direction in the road. Two cars running in the same direction, but the back one will hit the front one. When it hits it, you expect the first one, the one at the front, it will take, after impact, it will have a greater velocity. And the one at the back, it might change direction if it is light, if the mass is light, but it can complete in the same direction, but of course with less velocity after impact. It needs some sense when we expect the values for this question. Here we have velocities before collision. It is u1 means initial velocity and u2 means initial velocity for the second one. And here velocities after collision, here we'll deal with v1, which is final velocity for the first object, and v2, which is final velocity for the second object. So this is the blue highlighted one. It is the system after impact, and the pink highlighted operation is the system before impact. When you add them, they are equal. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Remember, you are adding for the whole system. and equating because it is conserved. Momentum is conserved. So, first of all, you have to choose a positive direction for velocities and apply the impulse momentum principle and or apply the principle of conservation of momentum. First of all, remember, we have to choose a positive direction for velocities. This is something else than choosing the positive direction of impulse. I'll give you an example now. Let's go. This question, this example is a particle P of mass 2 kilograms. Here it is. Its name is P. Is moving with speed 3 meters per second. The speed is 3 meters per second on a smooth horizontal plane. Thank God, no friction. And another particle Q, I drew it bigger to feel that one of them is weaker than the other. And Q, its mass is 3 kilograms, is at rest on the plane. Particle P collides with particle Q, and after collision, Q moves off with speed 7/3 meters per second. I'll reread it. A particle P of mass 2 kilograms is moving with a speed, so this is initial Q1, which is 3 meters per second on a smooth horizontal plane. A particle Q of mass 3 kilograms is at rest. It means initial velocity is 0. So the pink highlighted is the whole system before impact. Particle P collides. Particle P, this one is stopping, and the other one, it hits it. What do you expect? When particle P hits a stationary ball, the stationary ball, of course, will move forward. And the one which hit, the evil ball which hits this Q, it might rebound in opposite direction or it must continue. It depends on its weight and also on its speed. So what does he want? He told me now that the particle Q, after collision, Q moves off with a speed, expect it will move to the front, of course, with a speed of 7/3 meters per second. I'll write here 7/3 meters per second. This is the velocity of the second particle, but the velocity of the first particle is unknown. And I'll highlight the information of after impact in blue. Now let's read. Find the speed and direction of motion of P after collision. Find the speed and direction of motion of P after collision. Law of conservation of momentum states that the total momentum before impact, which is m1u1 plus m2 u2, is equal to the total momentum after impact, which is m1v1 plus m2v2. Now substitute the mass of P into its velocity, initial velocity, it is 2 times 3, plus the mass of the Q into its velocity, it is 3 kilograms times 0 because it was stationary, is equal to the total momentum after impact. Concerning P, its mass is 2 and its velocity, I don't know, it is V, plus the mass of Q, which is 3 kilograms multiplied by its velocity, which is 7/3. As you noticed, I should assume the direction of the positive velocities. I assume that the direction of the positive velocities is going to the right or going forward. Okay, so it means that U1 is positive 3. V1, I assumed it will continue forward and it will not reverse. I assume its direction is forward, 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 forward. Okay, so all of them will be positive. And let's see, calculations will show. When you calculate, you will get that final velocity here of particle P will be negative half after calculations. Negative half meter per second. Don't redo the question to change its arrow of direction. No, you'll just comment. You will say that, so P is reversed by collision. And its velocity will be half meters per second. Half meter per second. Just a comment, but never redo the question. So now part B. The question is, find the magnitude of the impulse received by P in the collision. Find the magnitude of the impulse received by P in the collision by P. Okay, by P. So I'll take the impulse, the mass of P, the velocities of P. So I'll write it here as follows. Let's go. Impulse of P is the change in momentum, which is mv minus mu. If we take m as a common factor, which is 2, so just a minute, I have to extract the ball P from the whole system. Take care, extract the whole P with the whole system from the system and show your assumption of impulse. The impulse, the positive impulse, show me like that, the positive impulse going to this direction because it will be opposite to the initial velocity, which is 3. So initial velocity, in the beginning of the question, I write u equals 3 because we assumed all velocities going forward are positive. First part, it is the assumption of the, collision is easy. But when you deal with velocities, you assume the positive direction of velocities in the beginning. When you deal with impulse, you have to extract the ball you are concerned in and assume the positive direction of impulse. Okay? And velocities will be consecutively following this assumption. So here, this is u, which is going to the right. It is negative 3 meters per second. And v, we know from the beginning, from the first part, that it's reversed. So v will be positive half. And now, mv minus mu, we'll calculate now. It is 2 into positive half minus 3. So the answer will be 7 Newton second. Law of conservation of momentum states that if you are concerned in the ball P to find its impulse done by P, it will be the same impulse done by Q. Let's take it as a challenge and let's go to the next page and see that I've written here or impulse done by Q, it is the mass of Q into velocities of Q. Here, as you see, I extract the ball Q from the system and it took the impulse from P in this direction. So impulse of Q, this direction, I'll assume it is the positive direction. This is the positive direction. And it was initially at rest. And then the velocity of Q, it was given in the question, which was 7 over 3. So this positive 7 over 3 because in the same direction of the impulse that we assumed. So IQ is mv minus mu. Take m as a common factor. M is 3, open brackets. Final velocity 7 over 3. Initial velocity is 0. Cut the 3's, it is also 7 Newton per second. It is the same like we did so you can use it as a check. You can find the impulse done by P and the impulse done by Q as a check. Both will give the same result. Now, next example, two particles, A and B, of masses 2 kilograms and 4 kilograms, respectively, are moving towards each other in opposite direction along the same straight line on a smooth horizontal surface. Here is particle A, 2 kilograms, and here is particle B, 4 kilograms. They are moving in opposite direction, so it means they will make an accident. These two arrows means opposite direction. Let's continue. Towards each other in opposite direction along the same straight line on a smooth horizontal surface, no friction. The particles collide. Before collision, the speeds of A and B are 3 and 2 meters per second respectively. So before impact, it means this is the initial velocity of A, which is 3, and the initial velocity of B, which is 2, but if you assume the positive direction of velocities, like this one is positive, so U1 is positive 3 and U2 is negative 2. This is before impact. After the collision, the direction of motion of A is reversed. Okay, it will be reversed. So the final velocity, yes, will be reversed and its speed is 2 meters per second. This 2 is opposite to the arrow I assume, so it will be negative 2. Then find the speed and direct expected. He will ask about B now. Find the speed and direction of B after the collision. I'll assume that B, because it is heavy, I assume it will continue, it will reverse direction just like A. They hit each other and then will reverse direction. So I'll say V2 equals question mark. And I have to assume all directions now. In the beginning, he gave the information that they are moving opposite to each other and make an accident. And he said that only A is reverse, but he didn't say anything about B. I'll assume that B also is reverse, and then let's see the sign. If it is positive, then my assumption is correct. So, law of conservation of momentum, I have to declare my assumption of the positive direction of velocities. So now, M1U1, let's say it, M1U1 plus M2U2 equals M1V1, which is after collision, plus M2V2. Let's calculate. M1 means 2 into its velocity, which is 3, plus M2, which is 4, into its initial velocity, which is negative 2, is equal to M1, which is 2, into its final velocity, which is negative 2, plus M2, which is 4, into V, which I don't know. Now let's calculate. 2 times 3 means 6, minus 8. It will be here negative 2 is equal to negative 4 plus 4V. Cross the bridge and change the sign. 2 equals 4V. When you divide both sides by 4, V is half meter per second, which is positive. It means that my assumption of both will reverse then is correct because the velocity now is positive. I should comment velocity of B is half meter per second and it is reversed after collision. I assumed it's reversed because I made one arrow going to the left and then after collision the arrow of B going to the right. It is reversed and my assumption is correct because the velocity is positive. Now find the magnitude of impulse given by A to B. By A means you have to consider the mass of A and the velocities of A. Velocities of A, which is 3 and 2, but take care, let's now consider the direction. if the initial velocity of A is in this direction and the final velocity in this direction, take care that the impulse, consider the impulse direction opposite to you. And right here I and positive sign, it means this is my assumption of positive sign for impulse. Now let's go. How do you find the impulse? The impulse is mv minus mu. So mv minus mu, I take m as a common factor, v minus u. Its mass is 2 and initial velocity, because in opposite direction of impulse, will be negative 3. And final velocity will be positive 2. So it will be 2 minus minus 3. 2 plus 3 is 5 times 2 is 10. Note, we have to find the effect of A on B because he wants to find the magnitude of impulse given by A to B. Thank you. That's all for now, and we'll resume solving more questions on the next video. Bye-bye.